gentlemen, let's begin again. This time we're going to talk about one of the applications of the conservation of momentum. We're going to talk about collisions today. All right, let's get into it. Now, one-dimensional collisions. We're going to keep it simple to start off with, okay? Now, let's, for sake of argument, define collisions. A collision is when two or more objects will strike each other and exert a relatively large force over a relatively short period of time. A car crash, if you will. So this force results in an impulse. Now, if you look at Newton's third law, you know that for every action, there's an equal and opposite reaction. We can actually apply this to collisions. So imagine that we get two balls ramming into each other in a head-on collision, shown here. So what's happening? We get the red ball makes contact with the blue ball, and there's a force applied in the opposite direction, which causes them to bounce backwards. Now, the balls will exert equal but opposite forces on each other, the way that this was set up. If you go back, take a look, yes, you will see that, assuming that their speeds and masses are the same, the force applied back will be equal. Sorry, no matter what, the force applied back should be equal. So if the two forces are equal but opposite, they must add up to 0, as shown over here. Okay. Now, we're going to look at the law of conservation of momentum. This is a fundamental law in physics. Like all conservation laws, it basically means that you start with what you have at the end. And so the work here that we're going to do for these problems, we call either one-dimensional or linear collision because it's all happening in a straight line. They're not going at angles to each other. Now, the law of conservation of momentum, while always true, it's easier if we look at it as an isolated system where no matter is entering or leaving and the energy remains constant. This means that there's no external forces acting on the objects. Okay, so let's take a look here. So you have to be careful when you solve these. We're going to look at two examples here. We're going to look at the collision of two objects might bounce apart and then if they stick together. Okay, so let's take a look here. I want you guys to pause this video and take a quick read. Okay, so we're got a couple things happening here. We're going to get a blue ball traveling at 8 meters a second. That's its speed. I'm going to label that a little B for blue. It has a mass of the blue ball is 0.15 kilograms, which means it will have a momentum of 1.2 kilograms meters per second. Okay, that's all well and good. Well, let's look at the red ball. Just give me 1 second here. Okay, it is striking a red ball that is not moving. Now, it does have a mass of 0.10, but its momentum is going to be 0, which will mean the total momentum will be easy to find. So the total momentum is just going to be 1.2 kilograms meters per second. Now, this is before the collision. What's going to happen after? Well, let's sketch it out. So let's look at the blue ball first. Okay, so the blue ball continues to move to the right. Its mass has not changed, 0.15 kilograms. Its speed is now 2.5 meters per second, which means its momentum would be, its momentum would be, give me 1 second, 0.15 times 2.5, zero point 0.375. Now, let's apply this to the red. Okay. Now the red one is going to be moving as well, One could make the argument it's going to be moving in this direction. Its mass is the same at 0.10. We don't know the speed. We're going to find that, but we do know what its momentum will be. Okay. We know that its momentum is going to be 1.2 minus 0.375. And that will be equal to 0.825. How to find the V? Well, the V is equal to the momentum divided by the mass. So this value for the momentum divided by this mass should be 8.25 meters per second. And there we go. So that's all well and good. Let's apply it to this one where they stick together. I want you to pause the video, read it, and see if you can draw what happens. Okay, so what's happening here is we've got a blue, so on the before side, I've got a blue piece of clay. It is shooting towards here. It is 2.3 kilograms. And it's got, a V of 12 meters per second going to the right. And a momentum of 27.6 to the right. So we're going to keep it positive. Kilograms, meters per second. Okay. Now we're going to take a look at the red one. Okay, so we've got a red one, and it is going to the left, so like so. It's got a mass of 5.6 kilograms. And its velocity going the opposite direction, so I'm going to put a negative in front there, is 8.1 meters per second. And it's going to have a momentum of negative 45.36. Okay, so if we look at the overall momentum, we will add those together and we will get negative 17.76 kilograms meters per second. So in the after part, when they're all stuck together, they're still going to be continuing to the left. Great. So it's going to have this momentum. Okay, so momentum is equal to mass times V. We know it's going 17.76 kilograms meters per second to the left. We know that the combined mass is going to be 2.3 plus 5.6. And so our speed is going to be 2.25 to the left. And the unit of that would be meters per second. And there we go. All right, so for some one-dimensional collisions. Now for example 2, when they're sticking together, this shows situations where two objects will stick together after hitting each other. This is a pretty common sort of question. So for example, a lot of car crashes, when the two vehicles get stuck together, that will be an example of that type as well. Or two train cars colliding and then locking together. Now it's also possible for two objects to be stuck together at the start and then go apart afterwards, and we would call that an explosion. And if this happens, we just have to kind of reverse things. So you'll be working on a couple of examples like that on your assignment. So please, by all means, take a good, quick look through the assignment number 3, one-dimensional collisions practice. This is all the work for this week. Please take a look through the assignment. It is not super duper long, and you can either submit that through Teams or you can email that to me by attaching it and putting as your subject line Physics 30 Week 4 assignment. And you email that to jeffrey.hakey@nwsd.ca. All right, good luck. Next week we're going to start off by taking a look at two-dimensional collisions. Good luck, and we'll see you next time.